All right, thank you. How about that? Is that better? Good. All right. So, turn some light on here so we can see. Come on, light. There it is. All right, so on the word problem here, I'm going to use a problem-solving technique for the word problem. I'm going to kind of go through that, set up the equation, solve it, and you might have went in a different order to which you established as the x and the y, but you can just flip your coordinates whenever you get done with the final answer to see what's up. All right, so problem-solving technique, the thing that we're going to look for is we're going to find the question first. So I'm going to go to the very end of the problem, and I'm going to go ahead and highlight it here because on your ACT Aspire you have a highlighting feature so you can use to highlight. So I highlight the question, so therefore it gives me a path as I don't have to read the rest of that stuff on the paper. And so I know the question is what is the price each of one of the senior citizens tickets and one of the child's tickets. And so now through there I'm going to trim the fat of the question. And trimming the fat of the question, first thing I'm going to look for is the mathy words. Sum, difference, product, quotient. I don't see any of those, but I need to skim it very fast to see that. So now that I'm going to go through other stuff, and I look for units, and I look for actions of numbers. Units and actions of numbers. Okay, and so my units is going to be price. Okay, that's going to be price is what it's going to be measured in, but here are the units of measure for each one. To signify the difference, I have senior citizen ticket, child ticket, and the only numbers that are in the question is 1 and 1. So that tells me a lot about the problem and the simple fact that my numbers shouldn't be real huge. Gives me context of the problem, context of my answer, to know that my answer should probably not be like $200. All right? And so the last part is I'm going to go through the passage and I'm just going to circle the numbers, okay? So there's a 3, there's a 5, there's 91, 69, 3, 3, okay? And so as I do that, now I still don't have to read the passage. I can use my question. My question says, what is the price of each? So I'm looking for price. Price is important. And then my units of measure are tickets and tickets, which are senior citizens, and child. And so therefore, those units of measure help me identify those up in my passage. Okay? And so the numbers that I have, I'm just going to write them down. My numbers are 3, 3, 69, 91, 5, and 3. And so now right beside those, I can see the units of measure. I know that the 69 and 91 are both dollar amounts because they're our largest ones for one, and they have a dollar beside it. Okay? And then I look right beside this. This is senior citizen. This is child, senior citizen, and this is child. Now, what helped me out in writing those numbers down is it created my equations for me. It created it for me. I see right here that this makes up that total and that the 5 and 3 make up that total. So there's my equations. So I know that 3 senior citizens tickets for whatever price they are added to 3 child's tickets for whatever the prices are is going to equal $69. And then I know that 5 senior citizens tickets plus 3 child's tickets, whatever the prices are, is going to equal $91, and I have 2 equations. Now, based on what we talked about yesterday, what would be the easier way, based on our characteristics of the problem, which would be the best technique to solve this? Why? That wasn't one of the characteristics. I only gave you 2 characteristics to look for, and this only fits one of those. Is there a coefficient of 1? No, there's no coefficient of 1, so I got to look to the second characteristic. What other characteristic do I have for the elimination? Yeah, are they both in standard form? And so since they're both in standard form, now let me examine it a little bit closer. I don't have a coefficient of 1, but I do have the same numbers. So if I just get the opposite of 1, I can cancel it out. That'll be for later. We're going to take these, and what do we have to do to solve this by graphing? Because that's what you were using whenever you solved this. You were using graphing. And so what I need to do, I'm going to establish this variable right here, c, as my y. So I'm going to solve for y. That will put it in y equals mx plus b form. All right, and so basically this is going to represent my y. This is going to represent my x because that's what standard form would look like, correct? All right. And so let's take this one right here so we can go ahead and make that into y equals mx plus b form. All right? And so I have 3s plus 3c equal to 69. I've got to move this by doing order of operations. From which way? Order of operations from which way? Well, we got both options, so now somebody else got to pick a side. Top to bottom or bottom to top? Which one? We said it both again same time, so we're even again. We got 2 and 2. What'd you say over there? It's not top to bottom because this is not simplifying an expression. This is solving an equation. I would really prefer you to think before you just say something. Think a second because I'm going to come back with why. Well, because it's the first one that came to my brain. That doesn't work for an explanation of why you chose that path. Look at the characteristic. Know that you're solving for C. Solving means bottom to top. Okay? So I'm going to subtract this because it is added. And I'm going to be left with 3C equal to negative 3S plus 69. How do I get C by itself? Because it's multiplied, so I divide it. And so the first graphable equation is going to be negative s plus, and doesn't 69 divide by 3? 23. Very good. So there's my first one, and if I wanted to, this is going to go in my calculator as y1 equals negative x plus 23 because I don't have c's and s's in my calculator. So that's the first one. Any questions on that one? Once again, what I want you to examine here is how long it's taking us to go through this process. I can solve it by graphing, but it's taking us a while to get to this process. Yeah, we all like it whenever we get done and we can put it in our calculator and we can graph it and it does the point of intersection for us. However, we forget this process, maybe because I'm doing it. All right? And so now let's take the other one. We're going to find it. 5s plus 3c equal to 91. So this is going to be the first equation that we'll graph here in just a minute. Somebody bring me a calculator, please, so I can graph it here in a minute. All right, and so I'm going to solve it using, I want you to be able to do it. Yeah, I want you to get a calculator we're not using. I want you to be able to follow me. All right, and so solving, bottom to top, top to bottom. Very good. Thank you for thinking about it. And so therefore, I'm solving for C, so subtract the 5s. I'm left with 3c equal to negative 5s plus 91. Now we divide by 3. And I'm left with c equal to negative 5 over 3s plus, does that simplify down? Or does it give me a decimal of 0.333333333? So I'm going to leave it, remember? I'm going to leave it as a fraction. You're going, oh my God, I can't handle those numbers. The calculator is going to. And so how does this convert into our graphing form? This will be y2 equals negative parentheses 5 divided by 3, close parentheses x, plus open parentheses 91 divided by 3. And that will take care of it in my calculator. Everybody okay with that so far? This one is dead. Can I have another? Okay, what's confusing about that? Just going from S's to C's and X's and Y's? Not today, we won't. I can do it not on here because I don't want to, when it says by graphing, I don't want us to go into that yet. All right, and so let's look at this graphable. So y1, so I hit y equals, my y1 is going to be this equation right here. So it's going to go in as negative x plus 23. All right, and this is the one we have the most trouble with because it has the fractions in it. And so it's going to be negative parentheses 5 divided by 3, close parentheses, x plus, open parentheses, 91 divided by 3, close parentheses. And that's what it's going to look like in my calculator. I hit graph. Oh no, it didn't show up, so I didn't do it right, correct? Why did it not show up? No, I put it in exactly right. Anybody remember what the answer was for this? Ma'am? Right, I have to zoom out. I have to get bigger. It was 11 and 12, and this is in a 10, 10, negative 10, negative 10. Okay? And so I'm going to go zoom out. There it is. And there it is. Okay? And so now I go second trace. We do not speak of trace. Intersect. I'm going to choose that one. I'm going to pass the point of intersection for this one. Boom, boom. 11, 12. So, what I have to do from here, what was my x? Which ticket was my x? The senior citizen was my x. Therefore, Childs was my y. Does the answer make sense according to a price of one of those? Yeah, it does. So my answer in coordinate form is 11, 12.